Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Zainab, who will be doing a presentation on ROS 2 basics in 5 days with Python. So she will demonstrate her code base working on a real robot, and then she will take us through um, how she managed to do it, and also give us a detailed explanation of what's a code structure like. Alright, so I will hand over the platform to her, and she will begin the demonstration of the code working on a real robot, and then we'll get into the details about how she managed to do the project. All right, over to you, Zainab.
Thank you very much. Okay, so I will start the. I think I'm gonna move it a little bit to a better
Perfect.
position.
Yeah, okay, that's looks good.
Mm,
All
just turn
right.
it a little bit. Yeah.
Okay.
Okay. Correct. Oh, just wanted to move it a little bit here more.
All right.
Right. And then no, the other way. Uh, 1 moment. Perfect. Okay.
All right.
Um. So I'm gonna run the ID now. Okay. I think I'll just put this here. Here. Okay. So the robot should start moving. It should first start finding the wall,
Okay.
and then when it's found the wall, and then it's gonna turn around and then start the robot following
Okay.
the wall following. Oh, it's not starting. That's interesting. Let me see. Let me stop it
Maybe
and
move
run it.
it back a little
Let me
bit.
try to. Yeah, that's what I was thinking. Move it back
All right.
a little bit, and then let me try again.
Yeah, there we go.
Looks like it's catching. Hmm.
Looks
Okay.
like it
Oh,
found the wall. Okay, there we go.
yeah.
All right.
Okay. Hmm. Seems to be lagging. Yeah, I think it's pretty good.
All right. Let's see how it finishes, and then we can get into the details
Yes.
about that.
Okay. I actually had a presentation, like a short presentation slide to present
Yeah, it's
to
good.
just share how.
Once
Okay.
once we get to the beginning, and once the robot gets to the beginning, then you can go ahead with your presentation.
Okay.
Okay, there we go. Was it supposed to stop there, or did it miss the start point?
Yeah. Technically, yes, it is supposed to stop there, but
All right.
um, I was having issues with getting it to stop, like right there. So,
Okay.
but let me stop it myself, and I'm gonna run through the presentation real quick, just to explain what I did, and then perhaps go into why it didn't stop.
It's
Um,
fine. You can take your time. I think you've got about
okay,
15 more minutes to do the presentation and to explain as
okay.
much as possible, and then I will let you know when it's time for the questions.
Okay. So this is a short presentation.
All right.
Um, so just the title of the project, which is the Turtlebot project.
Okay.
Um, and then this was just a little about me. My name is Zainab Aderoju. I'm a student at the University of Houston,
All right.
and I'm senior majoring in electrical engineering. So I'm taking this course as an ROS course as an elective.
All right.
Um, yeah. So the goal of the project was basically to perform three steps. The main of which is to do right hand following. Follow the wall and avoid obstacles.
Mm-hmm.
But first we have to do three steps, which was to first find the wall
Okay.
using the service server, and then when it's ready to follow the wall, and as it begins to follow the wall, it needs to record odometry as the wall is being followed, and it's supposed to be given as feedback
Okay.
using the action server. And then, yeah, start the wall following using the action and service client.
Mm-hmm.
But one thing I noticed while I was working, when we were working through the project, was that the real robot and the simulation had some differences in laser readings. So the index for the front reading for the laser was different, and it took a couple of tries to get that. We didn't realize that the first time until we saw that it wasn't, when we tried to connect it to the real robot, it wasn't uh doing the same things until we tweaked the values.
Okay.
Um, but this was my wall following logic. This was for the part one of the project, which was to just at least get it following, not even without calling the service or the action. This
Okay.
was just basic thing. Um, Getting the laser readings from the right laser readings and the front laser readings, and then making sure that the right laser readings were between zero point 0.2 and zero point 0.3
Okay.
meters, and that's when it could move forward. But as soon as it was getting too close to the wall, we had to like get it away from the wall. So that's why we increased rotational speed in the opposite direction.
Okay.
And but we didn't also want it too far from the wall, so we just wanted a balance. And then as it's following the wall, the front laser readings, we want to also be checking that it's less than zero point 0.5 meters so that it doesn't hit the wall and it turns around.
The one that's directly in front
So
of it.
my codes, huh?
The one that's directly in front of it, right? Is that the
Yes,
laser?
the front, yeah, the front laser, the reading distance that's directly in front of it.
Right.
Yes.
Okay.
Um, yeah. And then so for the code setup, I I had my main, well, I the way I wrote this down, I kind of wrote it kind of backwards. But the first thing we do is we have the service server that calls the service. Oh, I don't know what happened. We calls the service, and then it looks for the wall using so the logic for the wall finder script is to look for the shortest ray. So that's what we know that, okay, it's the wall.
Okay.
We turn towards it, and then we make sure that we're aligned with the wall, and then we can start the wall following. But before that, we also have an action server script. We call it should record the odometry of the robot,
Okay.
and then updating it every second.
Mm-hmm.
And it calculates the total distance moved as we move.
All
And
right.
then we have the wall following script. Yeah, but this was like my general overview flow chart. I think that's the end of the presentation. And then I can go into my code. So I think I'll just start with the server since that's the first thing that
Okay.
happens. Um the first thing that happens, of course, this is our service server script.
All right. Can you enlarge it a
And
little?
so we Yeah, let me enlarge it. Yeah. Yeah.
Yeah, okay, that's perfect.
Yeah. So we have the service. It subscribes to the laser scan and also the publisher to the movement. We publish movements to the robot.
Right.
So it reads the front reading and the right laser scan reading. And then I also set the minimum. So because we want it to read the shortest ray, I set the minimum reading in the ranges of the laser scan readings. And then I set that as my target values. That's what I want my front. So I want my front ray to align with that so I know I found the wall. So I did that. And what I did was I set up state flags because um as an advice from my teacher, he said it's better to have state flags rather than just having while loops.
Okay.
So I had state flags to let me know that okay, I'm at each step of this process. Okay, so at this state flag, the first one is like, okay, I'm finding the wall. And then I did that. I set a difference with some allowance just in case because we don't if it doesn't match the exact value, I wanted there to be like an accommodation for that. So
Okay, I see.
I did that. Okay, yeah, this line, just leaving some space just so that okay, even if it's near enough,
Mm-hmm.
then it should identify that as the shortest.
Okay, I see.
I did that. As soon as I did that, I increased the state flag and then move on to the next loop, which is to turn the robot. So once
Mm-hmm.
it's found it, it moves forward a little bit. Once it's moved forward a little bit, and it's the distance between it and the wall is less than zero point 0.3 meters.
Okay.
I want it to stop, and then the wall state increases again. And then I did that again for the turn. So basically, I did that, and when that's done, it should say that the response for the server is true,
Okay,
and
I
then
see.
it should be ready to start the wall following. Another thing to note was that I actually created another package for my custom interfaces because um we had to use a custom interface for the server.
Mm-hmm.
So I created a package for that and then imported it into my wall following
All right,
package.
I see.
Um, yeah. And then another thing was that we also called this synchronously. I'm going to go into the wall following. So in
Right.
the wall following callback, I called the service synchronously because I don't want anything else to happen while I am doing like while the service is happening.
I
So I
see.
want the service to be completed
All
first.
right.
So that's what I did. Yeah, I'm trying to look for the line. Okay, perfect. Okay, let me go back. Let me just go back to the beginning. Okay. So this is the wall following. This is the main script. So
Mm-hmm.
in the wall following, I had initially set up my logic of the wall following logic to subscribe to laser scan and the publishing movement.
Mm-hmm.
But then after creating the service, I then created a service client so that it could call the server.
Okay.
So I'm trying to look for the line where I call. Okay, so this is where I call the service. So here it would have been call async, but because I wanted it to be synchronous, I called it synchronously.
Okay. Okay.
Um, so onto the Odom recorder. So here, what we had to do, which was part three, we wanted to create an action server where we are recording the distances as we're moving, and so it keeps checking, and we have a mathematical equation where we keep calculating the distance moved using the hype function. I'm gonna scroll down to it. But here we subscribe to the odometry.
Mm-hmm.
So this is what is recording the X, Y, and angle positions, but we only use the X and Y positions.
Mm.
So I here I get the first value. So I have a callback that I get the first value from the odometry reading. I store that in a variable, and then I keep updating every 1 second. So this was here. I was like, okay, wait every 1 second before updating.
Mm-hmm.
And then I calculate the distance between the last one and the one that was previously recorded. So it's always updating. And then every time I update it to total distance. And on the side, as I get every reading, I'm also appending it to an array. So when the wall following is done, it should output a whole um, list of X and Y values.
Mm-hmm.
So, but for this one, for the Odom recording, I called it asynchronously in my wall following code.
All
So
right.
here, right here, I called it asynchronously. So technically,
Why did you have
well,
to
the
put it
funniest
asynchronously? Just curious. Um,
and
can you
not
explain your
synchronous.
logic
I
there?
mean, yes. Okay. So my logic for it is the synchronous for the server is I don't want anything else to be happening then. But while I'm running my action server, I still want it to be doing the wall following. So I want both of them to run at the same time.
Okay, so
So that
you
was
still
why
wanted
I
to have it updated, but you don't care when it happens.
what do you like?
You still want to have it
No,
updated, but you're not worried about when it happens, right? Is that
well, my thinking was more like, okay, if I call this service first,
yeah?
when the service is done, that's when the action starts. And then it doesn't matter um if it's still recording,
Oh,
like
oh, it isn't.
like as it's moving, it should be recording.
Right, right. So if it's moving and it's supposed to be recording, right? Um,
Mhm.
that's the case when it has found the wall, right? And then during the course of
Yes.
finding the wall, that's the one that you said you wanted that to be synchronous. So you wanted that to happen before anything
Yes.
else starts, right?
Yes.
So
Yes.
now the fact that you now go on to use an asynchronous mechanism of the update, right? Does Do you really care when the update happens, or you just want the update to happen when your control loop finds time to update that? Because I see that um,
Uh,
during the course of
oh.
checking for laser scan data to figure out are you still close to the wall or not, you don't seem to be checking
Mhm.
laser values. Are you checking the laser scan data to check are you still within
In the
the 0.3?
odometer,
Yeah, no, no, no.
in the wall following here.
Yeah, I think it should be at the top. Let's go to the top a little.
Yeah.
Where Oh, you remember when we spoke about using states, right?
Yes. Yes.
So
That was the wall finder. Yes.
right, okay. So that's the warfighter. Do you continue to use states also when the robot is actually following the wall, or you just transition
No,
from
I
the
don't.
follow wall state?
No.
Okay, there we go. Now,
Yes. No. No.
when
No.
it's
I don't.
following the wall, this is where I wanted to get to. When it's following the wall, do you constantly check for laser scan readings to see if you're still point 0.3 point 0.3 meters from the wall? That's 30 centimeters. Do you constantly check on that topic, or you
Yes.
just
Yes.
wait until
That's
you
the
get to
main thing.
right?
That's the main thing in the wall following. So yes, I am still checking.
Okay, okay,
I'm
yeah,
still checking to make sure that it's within. Yeah.
all
That
right,
it's within that. Yes. Yes. Oh, I was confused about the question, but yes, that I still check it.
all right.
But I only had a state flag for the wall finder code.
Okay, now
I only had a
it
state
seems
flag.
like we're already getting into the questions here. So would you say to me that was the reason for you having to use re-entrant callback groups, right? Is that the reason for needing multiple threads? The fact that it's constantly you have to have the
Yes,
laser scan
exactly. I
reading.
wanted them to all be running.
Okay,
Yes. So this re-entrant callback, yes. I did that for every single one of them.
right, right. Okay, okay. Yeah, I wanted to see if you could at least give me the logic for that, because you could have just checked and not keep checking, right? Um,
Oh no, no, we need it to keep checking.
okay, good, good. Okay, you can go
So
ahead.
yeah, yeah. I don't know. When did I stop? Okay, yeah. So and then it's recording the total distance, and then the when it's done running a lap, and where we know that is if the self distance is less than 0.05. So that's how we know that okay, the lap is finished, and then we send it to like, okay, the goal has succeeded, and then we give a result of the X and Y values that we had been recording as we went along
Right.
with the code.
Okay,
And yeah,
on that one, I would like to hear what your explanation would be. Why do you think the robot missed there? Did not stop at the beginning, right? If you're doing that check, what do you think could be the reason why it didn't stop?
what I'm thinking is okay, so I think my mistake was probably changing this to or just before the meeting. I had put it at and because our teacher suggested that the self total distance be greater than one.
Okay, okay.
But I think my mistake was probably not was probably saying that should have added another callback where I said once the action has succeeded, then we can stop the robot. Um you just publish twist to the robot to get it to zero. So I think that was something that I missed and didn't notice
Mm,
until
okay, okay.
I
So
did.
I'm thinking if you record the initial point, right? So if you record your initial x and y, right? Then
Yes.
um, every other time your robot is updating the odometry values, right? It will update with reference to that beginning, right? And
Mm-hmm.
as you go round and round and round, is your robot going to check for the x and y values as the basis for the fact that it has come back to the very beginning, or it will check odometry readings, right? So what I'm getting to here is, is your odometry checking for x and y values, or it's checking for total distance traveled? That's where I want to get to.
Okay, so we were in odometry, we were calculating two distances. So it is checking for, so here, if you see, um, I have, wait, where it is it? Okay, so I have two. I have self distance,
Mm-hmm.
which is calculating the total distance. This is in reference to the like every last reading, and then it keeps adding to see the total distance. So at every point that it's so for example, if I was at point A to point B,
Mm-hmm.
it's already done that distance.
Mm-hmm.
Then it adds it, then it keeps it, and then point C to B
Mm-hmm.
gets added. So in essence, it's actually adding it in layers
Cumulatively.
and then it's cumulative, exactly. So it's
Right.
cumulative.
So it doesn't
So
care if
that's
it's the same
calculating that.
point.
If it's the same point,
Yeah, as in on the coordinate system, it doesn't care if it's the same point, because it's just considering how much did I travel from the last point to this one, right?
yes,
So
for that
therefore,
one,
yeah,
for total distance.
I see. So clearly, you don't suffer from the predicament that I was trying to explain to you earlier. That if you use the coordinates themselves, then you would not be able to keep track of odometry as clear as having to use the method you did. So well done on that. That's what I wanted to get to.
Okay. No, we're not. It's doing it accordingly as we go.
All right, all right.
So yes. And
Um,
then let me see. Hmm.
I think you were about to go to the wall find. Is that right? On
Yes,
the script
yes,
that
yes.
you're
The
explaining
wall
here.
following.
Oh yeah. Okay. There you go.
Yes. Yes, perfect. Okay. Yeah, so this was here. I called it as a client in my wall following
Mm-hmm.
script. And then I also have my callbacks for it. I also have my reentrant groups. This here was just these were just values that I initialized, which was these were for the wall following logic like point 0.5, the front limit point 0.5 to minimum and max. Um and this was oh
Yeah, it's fine. That's all
oh
right. You have already done that.
okay. I'm scared. Yeah. So, and then this is the function to call the service, function to call the action. Um, this is the feedback. This was what I was trying to figure out why. this wasn't, I'm trying to figure out why this wasn't printing out because
Okay.
the current total distance is meant to print out.
Okay, I see.
And then the rest of it is just my um, wall following logic, and then just executing everything, my main function.
All right.
So,
I think that's good. Well done on your explanations. Let's just get into the questions for now to see if I've tried to ask you as they come. So let me see if I still have any more questions.
okay.
About the you spoke about the fact that the your configuration for the simulation and for the real robot was a little bit off. Can you just take me through how you managed to correct for that? How did you do it to get it to work the way you want it to work?
To be honest, so we realized this like early on when we're still kind of struggling.
Right.
Um, so because we had first part for our class and we didn't understand until we with the notes, we were thinking maybe we got the position of like we wanted to figure out where the robot was starting from. Like, is it
Okay.
starting from the left? Is it starting
The
from the
initial
right?
index. Okay.
So what I yeah, so for the index, what I basically did using the notes, which was like I ensured that the number of readings was like, for example, I printed out the ROS2 topic info. So I could see what it was doing and I could see using the range marks and whatever, I knew
Mm.
that okay, this thing is reading 720 readings. So I did a lot of trial and error trying to figure out the index. So
Okay.
that was how I figured it out for the simulation. But then when we got to the actual real robot, we realized that okay, the simulation and the robot are different. And
Okay.
so I was a little bit confused about why there was an offset, but then we just did offsets of 90 degrees to try to test and see which one of them would work.
So you kind of
And
did
then
it
we
in
eventually
stages.
got it. We did it in stages,
Okay.
yes.
Okay, that's good.
Yeah.
That's good. At least you didn't just go for one big value. Yeah.
Oh
Uh,
no, no, no. There was a lot of time like spent like drawing it out, like, okay, this is not wrong. And then for like I have I could show you my really old code, but we had just a bunch of we would put the robot in one spot
mm.
and try to see, okay, but and then would print a bunch of indexes and then would log it and see which of them was right. Like, okay,
Okay,
if
I
I
see.
put
I
this
see.
left index as 270, yeah.
I
So
see. All
that
right.
was how we kind of figured it out.
Okay, that's good. I've already asked you about how you calculated odometry, right? And I think I'm satisfied with your explanation. Let me see if I still have any other questions. So, the idea of states that came out is interesting to me, right? It's like you are
Mhm.
saying before transitioning to following the wall, you have to, well, yeah, to transition to following the wall, it's a different state. Is that right? Am I getting that correctly?
To transition to follow the wall,
Yeah. So
mhm,
what I'm saying is that
yeah.
finding the wall, that's another state. Then following the wall, it's another state, right?
Okay, no.
Okay.
So I only did state flags for the process to find the wall,
Okay. Yes, that's
not
where
as
I
it
want you to get into
follows the
details
wall.
about.
Okay, so not as it follows the wall. So, for example, because to find the wall, we have to first look for the shortest way, then move towards it, then turn around.
Mm-hmm.
So it was a lot of while loops.
All right. I
And
see.
my professor suggested that it's better that, okay, so it's not just running, it's better to once we have satisfied a state,
Mm-hmm.
then we can move on to the next while loop.
All right. All right.
So yeah, that was the suggestion
Okay.
that we followed. Yeah.
I like that logic. And so you had initially implemented while loops, and he referred you to this. Okay.
Yes.
And
Yeah, just while loops. And it wasn't seamless. It was quite like it was just like only it would just turn and it would just never stop turning. It wouldn't
right. Right.
it was
Right.
just yeah.
So
So it
you
was hard to
minimize what
break
it's
out.
trying to do by moving from state to state. Okay, that's
Yes,
where I wanted us
exactly.
to get to. All right. Very nice presentation. Zainab. So I would say congratulations on your work on this, and also
Thank you.
having to get along with texting and trying to reconfigure and find out if your index matches what you got in simulation. So well done on that. Other
Thank
than
you very
that,
much.
we'll wrap up here and then we'll finish our meeting on Zoom. All
Okay.
right, everyone. So this was Zainab's presentation, and we would like to encourage all those who would like to get certification on the courses that we do offer certificates on. We encourage you to keep pushing your ROS learning and take it one step at a time, one course at a time, one certification at a time. Until next time, bye bye.